August 25, 1944. Highway N13, northern France. German officers from the 21st Panzer Division stood beside the road, their Wehrmacht uniforms dusty and torn, waiting for American transport trucks. They had surrendered 2 days earlier after their fuel ran out 30 kilometers from the front lines, not destroyed by superior firepower, not outmaneuvered by brilliant tactics. Simply stopped because their supply wagons, pulled by exhausted horses, could not keep pace with their retreat. What these officers witnessed in the next minutes would challenge every assumption they held about modern warfare. An American convoy appeared on the horizon, not a dozen trucks, not 50. Over 200 GMC vehicles stretched in an unbroken line, each one loaded with supplies, moving at 40 miles per hour. Every truck identical, every load standardized, every driver maintaining precise 60-yard spacing. The convoy passed without slowing, a river of quota, mechanized efficiency that continued for 11 minutes straight. These German logistics officers understood supply lines, transportation networks, distribution systems, but nothing in their training had prepared them for this scale and speed. The Americans were moving more supplies in a single convoy than an entire German Panzer Division could transport in a week. They did not know that this convoy was part of the Red Ball Express, a truck network operating 5,900 vehicles carrying 12,500 tons of supplies daily. They could not comprehend that this was merely one route among dozens, and they had absolutely no concept of the mechanical revolution happening in American supply depots that made this impossible flow of material sustainable. The forklift. A machine so simple that German military planners had largely ignored it. A tool so effective that it had transformed American logistics into a weapon more decisive than any tank or bomber. These officers were about to discover that America had not just outproduced Germany. It had fundamentally reimagined how war was supplied. The mathematics of defeat were already written, though few German officers recognized them. The German military relied on manual labor for over 90% of its cargo handling operations. American forces had mechanized approximately 75% of similar tasks. A German supply depot required 140 men to unload and sort cargo from 10 trucks in 8 hours. An American depot with forklifts and 24 men accomplished the same task in 90 minutes. This disparity extended across every level of logistics operations. The transformation had begun in 1941, when the Office of the Quartermaster General recognized that war would create labor shortages that manual handling could not overcome. Representatives toured civilian factories using mechanized material handling equipment. They observed that forklift trucks and pallets, combined with standardized loading procedures, increased efficiency by factors of 5 to 10 compared to manual methods. The recommendation was immediate: mechanize military logistics completely. Congress allocated funds in September 1941 for large-scale forklift procurement. Then came the first obstacle. American forklift manufacturing capacity was wholly inadequate. Only 25,000 forklifts existed in the entire United States when war began, mostly in civilian industry. The military needed thousands more within months. Several industrial plants were hastily converted to forklift production. The Clark Material Handling Company, which had developed early forklift models in the 1920s, rapidly expanded production. By 1942, Clark was manufacturing 2,000 forklifts monthly, compared to 50 to 75 before the war. Throughout World War II, Clark supplied 90% of all forklifts used by American military forces. But machines alone solved nothing without a revolutionary change in how supplies were packaged, stored, and moved. Enter the pallet. Before 1940, pallets existed but were not standardized. Hundreds of different sizes circulated through American industry. Military depots receiving supplies discovered that incoming pallets often could not be reused for outbound shipping. Forklifts designed for one size could not handle another. The inefficiency was staggering. In 1942, military logistics commanders ordered immediate standardization. The Navy adopted the 48 by 48-inch pallet for ordnance. The Army followed the same standard. The Quartermaster Corps selected 32 by 40 inches for most supplies, recognizing it would serve 85% of requirements. By 1944, only 3 sizes remained authorized: 32 by 40, 36 by 48, and 48 by 60 inches. This standardization created something unprecedented in military history: a completely interchangeable supply system. A pallet loaded in California could be handled by any forklift in any depot in England, France, or Germany. Reuse rates skyrocketed, loading times plummeted, and the German military, still moving supplies in wooden crates loaded by hand onto horse-drawn wagons, found itself competing against an industrial system it could not match. The impact became visible in every theatre of war, but nowhere more dramatically than in the European campaign after D-Day. When Allied forces landed in Normandy on June 6, 1944, the temporary port facilities known as Mulberry Harbours had to process incredible volumes of cargo. By the end of June, they had unloaded 170,000 vehicles, 7.5 million gallons of fuel, and 500,000 tons of supplies. German logistics officers studying Allied operations were baffled by the speed. Intelligence reports noted that American depots unloaded cargo ships in a third of the time German ports required. The secret was not more workers, it was forklifts and pallets. A typical American supply ship carried cargo preloaded on standardized pallets. Forklifts moved these pallets from hold to deck. Cranes lifted them to the pier. More forklifts moved them to sorting areas. Additional forklifts loaded them onto trucks. One pallet might be handled by 6 different forklifts in 6 locations, but it was never manually unloaded and reloaded. The contents remained secured from factory to front line. German ships, by contrast, required manual unloading of individual crates. Dock workers hand-carried items or used simple hand trucks. Each transfer point meant another round of manual loading and unloading. The time difference was dramatic. The error rate was significant. The manpower requirement was unsustainable. September 1944 brought thousands of German prisoners to staging areas before their transport to America. Here, captured German officers witnessed their first close view of American logistics in operation. Ports like Cherbourg processed supplies 24 hours daily. Under floodlights that turned night into day, German prisoners watched small vehicles with vertical masts moving palletized cargo with impossible ease. Each machine, operated by a single soldier, lifted loads of 3,000 pounds to heights of 12 feet. The machines moved smoothly, quickly, precisely. Intelligence reports had mentioned American mechanization, but reports conveyed statistics, not reality. Seeing a single American soldier, seated comfortably in a forklift, accomplish work that would require 12 German soldiers with hand trucks was psychologically devastating. Officers who had studied logistics at German military academies watched American operations with growing comprehension. What they were witnessing was not just technological superiority, it was a fundamentally different philosophy. The Germans had designed their supply systems around available manpower. The Americans had designed their systems to minimize manpower requirements. German logistics depended on skilled individuals. American logistics depended on efficient systems. The implications were profound. The journey to America reinforced these lessons. Liberty ships carrying prisoners had been built at rates German officers considered physically impossible. The ships themselves demonstrated systematic organization that seemed almost obsessive to German military minds. Every pipe was color-coded, every valve was labeled, every system had redundant backups. This was not how German military equipment was designed. German engineering emphasized craftsmanship and performance. American engineering emphasized standardization and mass production. The Germans built superior individual machines. The Americans built superior systems. Upon arrival at American ports, prisoners were processed through logistics systems that demonstrated American efficiency at every level. Supply operations issued uniforms, blankets, toiletries, and personal items in assembly line processes. Each prisoner received identical items. Nothing was negotiated or customized. Everything was pre-packaged, pre-portioned, predetermined. The supplies came from depots where forklifts had loaded them onto pallets, where other forklifts had moved them to transport trucks, where still more forklifts had unloaded them into distribution areas. Not one item had been manually carried more than a few feet. Prison camps, built to house German and Italian prisoners, were monuments to American construction capacity. Facilities like Camp Shelby in Mississippi had been built in 4 months. They housed thousands of prisoners in wooden barracks with electric lights, running water, flush toilets, and steam heat. Camp supply warehouses were larger than many German factories, and they operated with small staffs using forklifts. By November 1944, labor shortages in American agriculture led to prisoner labor programs. German prisoners were trucked to work sites across the United States. This decision, driven by necessity, gave these men direct exposure to American logistics at the ground level. At warehouses and distribution centers, prisoners witnessed operations that defied their understanding of supply logistics. At a cotton warehouse in Mississippi, prisoners assigned to loading operations expected to carry bales manually, as would have been standard practice in Germany. Instead, they watched as bales were stacked on pallets by machinery. A forklift moved multiple pallets at once to loading docks. Another forklift loaded them directly into rail cars. The entire operation required 3 men plus prisoners who simply guided pallets into place. 20-man work details spent more time waiting than actually working. The psychological impact of this efficiency was profound. German logistics officers who had supervised supply operations for divisions with thousands of men watched 3 American workers with 2 forklifts accomplish work that would have required dozens of German soldiers working full shifts. The ratios were almost incomprehensible. What took German supply battalions entire days, these Americans completed in hours. And the American workers did not look exhausted. They looked bored. One German officer who had managed logistics for an infantry division made calculations in a notebook. In his previous role, loading 40 trucks with supplies required 160 man-hours of work. 8 men per truck, 2 hours per truck. Here in America, he watched forklift operators load the same quantity in 4 hours total. The American system used 96% less labor to achieve the same result. The mathematics were inescapable. This was not a marginal improvement. This was a fundamental transformation of what was possible in military logistics. At ammunition depots, the efficiency was even more striking. German officers watched Americans use forklifts to stack artillery shells on special pallets designed for the purpose. Each pallet held 12 shells weighing approximately 900 kilograms total. A single forklift operator could retrieve a pallet from storage, transport it to a loading area, and place it in a truck bed in less than 3 minutes. The same operation performed manually would require 4 men working 15 minutes. One American with a forklift did the work of 20 German soldiers in the same time period. The scale of American operations was equally impressive. At quartermaster depots, warehouses were larger than any facilities most German officers had seen. Some covered 5 or 6 acres under a single roof. Multiple forklifts operated continuously in organized patterns. Each forklift moved approximately 30 pallets per hour during regular operations. Each pallet held 1,000 kilograms of supplies on average. The mathematics were simple but staggering. 5 forklifts could move 150 tons per hour. A comparable German depot would require 200 men to achieve half this throughput rate. German engineering officers were particularly struck by how Americans had mechanized everything possible. Electric pallet jacks moved loads short distances within warehouses. Conveyor systems transported canned goods and packaged items between sections. Specialized forklifts with extended masts stacked pallets 3 and 4 levels high. Nothing was carried by hand if a machine could do it. This was not laziness. This was engineering efficiency applied systematically to every operation. These observations were consistent across prisoner camps throughout the United States. German officers sent to facilities in Georgia, Texas, Arkansas, Louisiana, California, and other states all recorded similar impressions. American supply depots achieved impossible efficiency through 3 key elements: mechanization, standardization, and systematic organization. Every depot followed the same principles. Every operation used the same equipment. Every procedure was documented in manuals that any trained soldier could follow. Engineering officers assigned to work at railroad yards watched as Americans unloaded freight trains faster than Germans could imagine. Forklifts drove directly into boxcars. They removed palletized cargo and transported it to warehouses in continuous motion. A 40-car train was emptied in 4 hours. In Germany, similar trains required 2 full days to unload using manual labor. The difference was not work ethic. German workers were not lazy. The difference was mechanization. Americans had tools. Germans had only muscle. At food distribution warehouses serving military installations, German prisoners encountered operations at scales that defied comprehension. One facility in Louisiana covered 8 acres under a single roof. The warehouse operated continuously in 3 shifts, providing supplies to installations across the southern United States. Automated conveyor systems moved canned goods from receiving docks to storage areas without human handling. Forklifts stacked pallets in aisles that stretched hundreds of feet, organized in grids that allowed precise inventory tracking. Electric vehicles carried supervisors through the facility to inspect operations. Refrigerated sections maintained precise temperatures for perishable goods using industrial cooling systems. The facility processed extraordinary volumes. On average days, 200 trucks arrived with supplies. 200 trucks departed with orders for military installations. Each truck was unloaded in 15 minutes using forklifts. Each truck was loaded in similar time. The warehouse moved 4,000 tons of food supplies daily. To put this in perspective, this single facility distributed more food in 1 week than many medium-sized German cities received in a month during the war's final year. American supervisors, often civilians with pre-war experience in commercial logistics, explained their systems to prisoner work crews through interpreters. One supervisor, a former grocery distribution manager, walked German prisoners through the operation. He explained that everything was standardized according to military specifications. Can sizes followed established dimensions. Boxes were built to hold specific quantities. Pallets were constructed to exact measurements. Trucks were designed to carry calculated loads. When everything is standardized, everything becomes predictable. When everything is predictable, everything can be optimized. The supervisor demonstrated the principle. He showed how cans of vegetables were packed 12 to a box. 40 boxes fit on a standard pallet, 20 pallets fit on a standard truck. If a military installation needed 480 boxes, the warehouse knew immediately that this was 12 pallets requiring 1 truck with space remaining for 8 additional pallets. The mathematics were simple because the units were standard. There was no estimation. There was no guessing. There was only calculation. German officers found this approach revolutionary. In German military supply operations, estimation was standard practice. Officers with experience judged by eye how much cargo would fit in vehicles. Sometimes they loaded too much and had to unload portions of shipments. Sometimes they loaded too little and wasted transport capacity. Experienced supply sergeants developed skills at estimating, but it was always estimation, never precise calculation. The American system eliminated estimation entirely through standardization. The psychological impact on German officers went beyond mere efficiency comparisons. What they were witnessing represented a fundamentally different philosophy of organization. German military tradition valued expertise, experience, and improvisation. Skilled officers and experienced sergeants who could organize complex operations through judgment and adaptation were highly prized. The system worked well when these skilled individuals were available. American military organization valued systems, procedures, and documentation. Any trained soldier could perform complex logistics tasks by following established procedures documented in technical manuals. The system worked consistently regardless of individual skill levels, because success depended on following procedures rather than exercising judgment. This difference had profound implications. When skilled German logistics personnel were killed, wounded, or captured, their expertise was lost. New personnel had to develop skills through experience, which took time and created inefficiencies during the learning period. When American logistics personnel were lost, replacements followed the same documented procedures and achieved comparable results immediately. The system was resilient because knowledge was embedded in documentation rather than individuals. German officers working at American motor pools witnessed this principle in vehicle maintenance. American military vehicles required maintenance just like German vehicles, but maintenance approaches differed fundamentally. American mechanics worked from comprehensive technical manuals that provided step-by-step instructions for every repair task. Diagnostic procedures were standardized with decision trees that guided mechanics through problem identification.